In this video, we are going to do 7.3. What I'm planning on doing is putting up some examples that we have gone through previously, and you'll notice that they follow the same pattern that they have in the past. So the first one we have is going to be number 1 in your note packet, and it is a plus 3 quantity squared. Now, you're going to see this follows really closely to what foiling looks like. If you look at this, the quantity squared means that you're going to write it twice. So a plus 3 times a plus 3. Now, we showed 3 methods in the last video. So what I'm going to suggest is you take one of your favorite methods and follow along. I will do all 3 methods just to refresh your memory for this problem, but then I will probably stick with the rectangle method for the remainder of the ones I will show. So the first one that we talked about was FOIL, F-O-I-L. And remember, FOIL stood for the acronym first, outer, inner, last. So with the F for this first one, we are going to take and multiply a times a, which is going to give us a squared. In the O, we will multiply the a times the 3, which is going to give us 3a. In the I, we are going to do the inner ones. So 3 times a is 3a. And then the last one is going to be your L, which stands for last. So you're going to take and multiply the last 2 terms in each of the groupings. So 3 times 3 is 9. So like we did before, I had you box in the O and the I because normally you will combine those two. There are a few exceptions, but for the majority of the time, you will be adding the 2 of them. So this is going to be a squared plus 6a plus 9. Let's look at another example of this. So instead of method 1, let's do method 2. Method 2 is known as the distributive. And remember, with the distributive property one, you basically treat it like you did when you multiplied a binomial into a trinomial or a monomial into a bi or trinomial. So we basically take, and I like to shoot the arrows over. So a times a is a squared, a times 3 is positive 3a, 3 times a is positive 3a, and 3 times 3 is going to be 9. Once again, you're going to notice that those 2 in the middle have the same terms, so therefore the same variables in the terms, which means you're going to add them. So we have a squared plus 6a plus 9. The last method that I introduced in the last video was called the rectangular method. So for the third one, so the rectangle method looks like this. We have an A and a 3 and an A and a 3. And if you remember right, we made a rectangle. Now in this case, it's going to be a square because it's a 2 by 2. We know that because I have 2 in the first grouping and 2 in the second grouping. As before, I reminded you about the signs. So if you have a positive, you do not need to show the sign. But if it was a negative, you would need to show your sign. So in this case, they are positives. Now, reminder with rectangle methods is you have to take and multiply to get in. So a times a is a squared, a times 3 is 3a, 3 times a is 3a, and 3 times 3 is 9. Recall from before, we said that the very first multiplication, if it's written as greatest to least in exponents, will be the highest exponent. And if it's wrote in a similar order, then the bottom one is going to be in the lowest form of exponents. So your middle diagonals combine. So I'm going to still come up with a squared plus 6a plus 9. And as you can see, they have about the same amount of work. All 3 of them are just different ways to organize your thought process. Let's look at another example. Okay, so in this next example, let's just do the rectangle method from this point on. What I'm going to do is give you an example here of 3x minus 2 raised to the second. So with the rectangle method in this one, we are going to take and write this in a square again because it's going to be a 2 by 2. Since it is quantity squared, we are going to have it up above and beside. And if you noticed, I put the negative with the 2 to help us remember that that really is a negative 2. So once again, we multiply to get in. So 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. And 3x times negative 2 is negative 6x again. The final multiplication is negative 2 times 2, negative 2, which is going to give me positive 4. The two diagonals and the 2 with the diagonals are going to combine and make negative 12. So my product is going to be 9x squared minus 12x plus 4. Once again, if you choose to use one of the other two methods, they do work out just as well. Now, there's always the question of what do I do if I have extra signs? Well, believe it or not, the extra signs work themselves out. So let's make this our last example before we get into some of the special examples. So I'm going to look at number 6. In the note packet, number 6 is negative 4p minus 3 quantity squared. We're going to treat it the same. Once again, it's a squared, so I'm going to have 2 of them. So I make the rectangle 2 wide by 2 long. So I have negative 4p and negative 3 and negative 4p and negative 3. When you multiply negative times a negative, it just drops the sign. So negative times negative makes that positive 16p squared. Negative times a negative is going to make that positive 12p. Negative times a negative, once again, is a positive 12p. And 3 and 3 is going to become positive 9. So basically what happened was all of your signs canceled themselves out and became positive. So once again, same rules hold. The biggest exponent comes first, 16p squared. The diagonal combines, and you're going to add 12p and 12p, which makes 24p. And then your final number is the 9. Now, so far we've been working with basically what these are called are perfects. A perfect means that the grouping is held as a quantity squared because the signs are the same, they are identical. So when we were working a little bit earlier on this is what we were calling. Now keep close attention to this particular type of binomial because we will see it again when we start factoring and we run into these. Okay, so now let's talk about what happens when we do not have a perfect, when we actually have a difference of squares. So as you could see before, squares is what was the magic key with that perfect part. So let's look at the second half of 7-3. And that's going to do your difference of squares. So difference of squares is what they like to refer this to. And it's still the product method. So you could do all 3 methods and it still works. So the beauty of teaching you the 3 methods is all 3 of those work anytime you are multiplying a binomial times a binomial. Now, if you're doing a binomial times a trinomial or a bigger poly, then the first method does not work. Okay, so foiling is strictly for a binomial times a binomial. But the other ones are going to be for something bigger. So let's look at this here. So here we're going to look at number 10. And number 10 is going to be x minus 3 and x plus 3. So as you can tell, this is just a binomial times a binomial. So any of the 3 will work. So like I said, I'm going to stick with the rectangle method. And I'm going to make 2 columns and 2 rows. I'll put the first one on top, which is going to be having the negative 3 with it. And the second one has no negative, so I'm just going to take and just keep it all without signs. We multiply to get in. So this becomes x squared, negative 3x, and then positive 3x, and negative 9. So you're going to notice something happens in the diagonals. My negative 3x and positive 3x are actually going to cancel each other. So since we know they cancel each other, we don't have to put a 0, we just drop them completely. So x squared minus 9 is my binomial answer. Okay, so let's look at another example. So let's look at number 11. So in this particular one, we have q plus 5 and q minus 5. Same thing that we did before. So let's make ourselves a nice rectangle, which, like I said, hymns more like a square. So the q plus 5 I'm going to put on top, and the q minus 5 I'm going to put on the side. And once again, pay attention, I put the sign there so I remember to multiply the negative in. So q and q, when we multiply in, becomes q squared. This becomes 5q positive, and this is a negative 5q in the next line. And a negative 5 times a 5 is going to be negative 25. So just like before, the two negatives are going to cancel each other out. So we're going to end up with q minus 25. And that is our final answer for that. Now, we have more cases of this. So right now we've been looking at the light fluffy stuff. So let's get into some more meat and potatoes of this. So when we look at this, I want to talk about numbers that are in front. So a lot of us like to shy away from these type of problems. So let's look at like something like number 13 here. This is 5a minus 1 and 5a plus 1. So as before, you could choose your method. Once again, I'm sticking with the rectangle. We know that we have 5a and a negative 1 and a 5a and a positive 1. It will yield the same outcome as before, only the numbers all in front of the a squared. So I'm going to get 25a squared, negative 5a, and negative 1. So in this case, we still have the diagonal that drops those out. So I end up with 25a squared minus 1 as my final answer. So I'm going to leave you with one now to work. So when you get done with this one, pause it before and then check your work. So for number 14, we have 1/4 b plus 1, 1/4 b minus 1. Now, like I said before, these actually have to follow the same rules we've been doing. So you may feel a little hesitant, but I believe you can do this. So pause the video, and when you start back up, we will work through this. Okay, so now that you've had time to work this, I hope you paused it. We actually come back to this. So we're going to multiply to get m. So 1/4 times 1/4 is the same as saying 1/16. And then b and b makes b squared. 1 times 1/4 b is just 1/4 b. Negative 1 times 1/4 b is negative 1/4 b. And then negative 1 times 1 is negative 1. So just like before, even though these are still fractions, the middle still drops out. So I'm going to end up with 1/16 b squared minus 1. The last question we're going to work on is just going to prove to you that no matter how you set this up, as long as you have opposite signs, you will still end up with a binomial answer. So the one I want to look at before we close this session is going to be number 18. So for number 18, we have 6a plus 1/2 b and 6a plus 1/2 b. Oh, I see what I forgot to do. The second one is a negative 6. So looking at the two groupings, they are basically the same. The only difference is the second one has a negative 6a. Since we have an opposite sign in one of the two of them, this still works to drop out our middle. Now, a lot of you guys may be hesitant because the b is not in the front. Well, folks, you can take care of that. Do that when you rewrite it into the rectangle method. So once again, we're going to take and we're going to make our rectangle. I'm going to rewrite this. I'm going to make this 1/2 b and then put my 6a after it. Now, I know that normally we tell you alphabetically put it there, but the negative sign seems to bother people. So if we rewrite it, we will have less of an issue. So this one's going to be 1/2 b and negative 6a. Now this looks similar to what you've been working on. So once again, 1/2 times 1/2 is the same as saying 1/4 b squared. And then this one here, don't let it bother you. 1/2 of 6 we know is to be 3. So 3ba, and once again, negative 3ba. Negative 6 times positive 6 is negative 36a squared. So as you notice in my diagonal, the negative 3b and the positive 3b are both going to cancel. Sorry, 3ba and 3ba. So when they drop out, I get 1/4 b squared minus 36a squared. And ladies and gentlemen, that is the correct answer. If it needs to be rewritten to satisfy your teacher, just rewrite it. You still have the work to prove that you know how to do the math. All right, good luck, and we will see you on the flip side.